So we need to be able to draw Lewis structures on the test. It gets asked a lot in the free response section. And the Lewis structures are representations that show all electrons, both bonding and non-bonding. So we need to not show just the bonding pairs, but also we need to be able to show the lone pairs on atoms. We've done this a lot in honors chem, so my guess is this is old hat for you, but find the sum of the valence electrons in the atom. So phosphorus has 5 valence electrons. Each chlorine, there are 3 of them, each has 7. That's a total of 26. If this is an ion, let's say it's a sulfate ion, which has a -2 charge, I'd add 2 more electrons. If it's an ammonium ion, which has a positive charge, it means it's lost an electron, and I would subtract 1 electron from the tally. Okay. Now, one of the important concepts here is the central atom is always the least electronegative element that's not hydrogen. Hydrogen can never be central, because if I have hydrogen and something else, this hydrogen effectively will have 2 + 2 or 4 electrons around it, and it can't. You know hydrogen can have no more than 2, so hydrogen is always on the outside. But other than hydrogen, it's always going to be the atom that is least electronegative that's going to be on the outside. Alright, so I want to keep track of the electrons. I've got 7 times 3 is 21, plus 5 is okay, so I've put phosphorus in the center. I've put 3 chlorines on it. They need a bond, so I've used 6 electrons. I have 20 left. So now you can draw these as dots, which is the preferred way. If you're lazy like me, or if you're just really sloppy like me, you can actually do this and get away with it on the AP exam. Okay, so now I'm giving everybody that's not part of the, that's on the outside, a full octet. So I have 8, 8, 8, and 8, and I want to see if I've used the right number of electrons. So I had a total of 26, which means 13 pairs. So I've got 4, 8, 12, 13. I had 26 electrons. That's 13 pairs. So this structure is good. It looks kind of messy, but it's a good structure. So we filled the octets of the atoms. We kept track of what we had left. We had another pair for the central atom. We put those there. Okay. So if you run out before the electron has, before the central atom has an octet, then you're going to need multiple bonds. So let me just count here. We have H, C, N. Hydrogen is 1. Chlorine has 4 valence electrons. Nitrogen has 5. That's going to be a total of 6. So I've got 2, 4, 6, 8, 10 electrons. Nitrogen's happy because it's got 8. Hydrogen's happy because it's got 2. But carbon only has 2, 4 electrons. So I have to take one of these pairs, eliminate from there, and put it here. Now this carbon has 2, 4, 6. Doesn't have enough, so I got to take another lone pair and move it here. So now this carbon has 2, 4, 6, 8. This nitrogen has 2, 4, 6, 8, and everybody's happy. Now we're going to form multiple bonds, and when we do that, the thing you got to keep in mind is there's only 5 atoms that will form 5 elements that will form multiple bonds, and they are known as the C-nops: carbon, nitrogen, oxygen, phosphorus, and sulfur. The C-nops. Okay.